Hey everybody, it's Eugene, and today we're going to be doing a very quick experiment. And what I'm going to do is I am going to use the LiDAR sensor and Recon 3D, and I'm going to be changing the sensor's position relative to the ground. And so what I'm trying to determine is what kind of data am I going to get if the sensor is not perpendicular to the surface that it's scanning. So if I had a wall in front of me and I turn this perpendicular, that's the best way to project the pattern on a surface and to recover information or depth information. But if I have the ground here in front of me and I point this way, so now it's parallel with the ground, well, that doesn't help me all that much. So I haven't done this before, but it's something that I've sort of seen in the scans that I've been doing, and I want to experiment with it. So what we're going to do is 3 passes. We're going to do one where I'm just going to walk straight down this parking lot here, and I'm going to have the sensor up basically like this, 90 degrees parallel with the ground, and we're going to see what that gives. On the next one, I'm going to change this. I'm going to rotate it about 45 degrees down, and I'm just going to walk with the sensor down about 45 degrees. And then on the very last one, what I'm going to do is I'm going to scan with this facing straight down, so it's perpendicular to the ground, and then we'll see what kind of data we get from there. So first things first, let me start a project. And I'm going to call this, I'll call this 90 degrees. So this is going to be 90 degrees. Well, not actually, I'm going to call it 0 degrees. It's going to be 0 degrees, and I'll do it to the ground. So this is where it's parallel like that. So I'll just go ahead and create. I'm just going to use the 5mm setting. No big deal. Save. And I'm going to turn around, and I'm just going to walk down here. And you'll see I'm just going to hold it straight up like this. And so I can scan this way. So, and I'll just walk, I don't know, maybe 20 steps or so. So here we go. I'm going to hold it up a bit higher and hit go. Okay, so it looks like it's scanning now. And I'm just going to go here like this. And I'm going to stop here in just a moment. So just about this far, up to about this truck, and I'm going to stop. Boom. Good. So I'm going to save that for later because we'll process it later. Let me come back here. So now I'll show you what I'm going to do. I'm going to tilt this down a little bit. So I'm going to take the adapter, I'm going to loosen this a bit, and I'm going to point it about 45 degrees. So it's not exactly, but tighten it up there. That's about 45 degrees to me. Looks good. So I'm going to create a new project. And let me go back here. I'm going to go new project. And we're going to call this one 45. Why not? Create. Use the same settings, and now I'm going to do the same thing. I'm just going to hold this up high, and I'm going to hit record. Okay, I'm going to hold like that, and I'm just going to walk until about the same spot. So now, not having done this before, I'm not exactly sure what I'm going to get, but I have a sense that if the data is more perpendicular, if the sensor is more perpendicular to the ground, I should get a slightly better result. So I'm going to save this one for later. Okay, and for this one, actually what I'm going to do is I'm going to extend the pole a little bit, and I'm going to hold it so that it's kind of like this. Like that. Okay, and then what I'm going to do is I'm just going to hold it up like this, and that's about 90 degrees, and I'll be out of the way so it doesn't see my feet or anything like that. So let me go ahead and make a new scan. I'll call this one 90. Okay, and oh, can't do that. Hold on a second. I'm going to call this one 90 degrees, 90D, why not? Okay, and I'm going to go save scan settings, and let me try this one. So I'm going to have it down, point it down to the ground. Let me hit record. It's recording, so I'm just going to come up here like this, and I'm just going to walk a little bit. About this far, and that's good enough for me. So I'm going to bring this down, and I am going to stop it. Okay, so I'm going to save that for later. So what I'm going to do now is I'm going to process these all on the cloud, and then I will go to my computer. I'm going to download the data, and then we're going to bring them into Cloud Compare. And we'll just do a quick analysis looking at all 3 point clouds, the one at 0, one at 45, one at 90, and we'll see what the data looks like. Hopefully we'll see some kind of a trend, or we'll see a benefit of being perpendicular to the ground. So we'll see you in a bit. Okay folks, well, we're back at the computer here, and all 3 scans have processed, and what I've done is I've imported them into Cloud Compare. So I'll start one by one here. So on the right, this is the scan that I did at 0 degrees. So basically I was walking with the sensor parallel to the ground. And so you can see that I have, well, a couple things that we can notice. First, the color is different, right? And so the exposure that it's getting from looking straight ahead versus down at the ground is going to be a little different. So you can see it's a little bit darker than the other two that are beside me. Also, I've caught a much smaller area. So I don't have as much data on the ground as I do on these other two. And if I zoom in, you'll see that I have these streaks. I've got sort of these noisy, I just call them streaks or artifacts or whatever. But you get the idea here. There's sort of these lines that just doesn't look clean. And so, I'm not exactly sure what that is, if that's part of the images from the photogrammetry that are overlapping. But let me make this a little bit bigger so I can get in closer and see. But yeah, you can get the idea. It's not the best solution here. And I got a lot of these stray points that were out in the distance. Now, if I go to the 45-degree one that's right in the middle here, you'll see that I cut a fairly wide area, being at 45 degrees. And if I get in, it looks a little bit better. So if I sort of scroll down, but I still get these patches here that are, well, just a little bit of noise or something that's going on. And especially on the edges of the scan. So you'll see that I've got a bit of noise here on the edge. So it doesn't look all that clean. But I think it looks okay. Like in the center, it's definitely an improvement in the color and in the quality of what I've got over here. This wasn't too bad, but I think this looks a little bit cleaner. And if we go over to the 90 degrees, now the 90 degree, you can see this is where I've got the sensor pointed straight down at the asphalt. And if I get in, you'll see that it looks much cleaner. If I go over here to the 45, you can see this looks like a mess. And if I move over, right, much cleaner, better data, not as much of these artifacts and that sort of thing going on. So I think, without getting too technical here, this makes a strong case for ensuring that the sensor is at 90 degrees to the surface that you're scanning. And so obviously here I just did the ground, which was really simple, but you can find yourself in an environment where you have a lot of different surfaces. And a car is a really typical example because you get curved surfaces, you've got vertical surfaces, horizontal surfaces. And so you got to kind of make sure that the sensor is always moving around and trying to get perpendicular to all of those surfaces. And so sometimes that can be tricky, and sometimes if you forget, then you may be missing some data, or what you might find as you start getting something like this, you get a little bit of noise. So, quick experiment, hopefully it proved the point. Thanks a lot, folks, and we'll see you next time. Bye-bye.